Hey everyone, how's it going? Today, the plan is to get our AI that was learning where the user clicks. We mostly completed the entire model yesterday, including the encoder and decoder, in a complete unbroken graph in Pytorch using all of the Pytorch native APIs, which is fantastic. Usually what I do is I break the graph, which means that I do a lot of, mixed device computation, mostly my own custom code written for encoding or decoding or manipulating the data on a CPU. And then, the batching, which is, probably the most important part of the performance gain that you get with the GPU to train the model with data in batches. So, however, I'm not necessarily gaining that benefit because we're only doing this on a per click basis. So it's an environmental item. When the user clicks, the AI will start learning. It will track the previous clicks and see and predict where the next click is going to be. And so that's the plan for today. We're going to visualize that click. We should be able to get it working. Also, I was thinking over the evening, we are tracking our losses and we're computing the loss for each training sample. It's not the cost. Although I would okay, that's another to-do item. I've got it. All right. So we need to add this to-do item, calculate the cost. To-do, calculate cost. In Pytorch native APIs or methods, Pytorch native methods. I know how to do that myself. It's really easy. Sum, divide by count. No problem. Is there a Pytorch native method? Let's start with that. Let's get a warm up. Let's do a warm up on this. We'll do this right here. We'll get warmed up on this. Let's go to our search engine and we'll do Pytorch calculate cost function. Here we go. Let's see if we can do that. Is there any data? Pytorch, you can calculate the cost function or loss. Predefined modules in yep, that's exactly what I want to do. I want the predefined cost. Let's see, lost backwards, let's see, a series, cost, average over each sample batch. Okay, perfect. Let's see here. There's a mean loss. Yeah, basically I want the mean loss over a series of samples in a batch. Or all batches, multiple batches. That's what I really want. The multiple batches, that's what I'm really looking for. Multiple batches. Yes, multiple. Calculate average cost over multiple samples across multiple batches. You should use the reduction parameter of your Pytorch loss function. Oh, or sum, depending on how you use the structure of cumulative loss. Okay, let us take a look here to see if there is anything that I want. Reduction none. Okay. We might have a few options available to us. Let's take a peek here. So what I'm looking at right here, of course, is, some Gemini results. I'm wondering if there is does average across mini batch per sample gradient, best way to compute average of multiple models. No, I want the loss. How are losses aggregated over multiple computed batches? No, because what's important is I want to see, you can visualize a chart of every single batch or that you've trained. You can do this, and it looks chaotic. And I want to see the average. I want to see sort of a trend. I want to see more of a trend. It's more revealing when we see it calculated over time. So that's what I'm looking for. That's what I'm looking for. All right, let me see here. One moment. Okay, clicking buttons. Excellent. Okay. Yep. Oh, hey, sorry. My chat wasn't working there. I didn't see. Folks were chatting. Sorry about that. I missed your chat messages. Oh, sorry about that. All right, Ian. Hi, how's it going? Ian, Kyle, how's it going? Jeanette, how's it going? Mishape. Sorry, I missed your chat messages. You guys, Joe Steven. If you say my name, I will give you all of my bits. Ian Bradfield. I missed your message. Hey. Hi, don't follow me. Okay, sounds good. Prime. Hey, say Steven. Sounds good. Thank you. Matthew Reisner. How's it going, Matthew Reisner? Hi. Welcome on in. Good to see you. Sorry I missed your chat messages there. My chat wasn't showing up. It's good to see you, Jules. Hey, Ian Bradfield, thank you for sending the clutch and 30 Jules. I was not expecting that. Thank you so much. Well, and another 100 Jules. Ian Bradfield, you're off to the races. Must be crisp. It must be the holidays. Thank you. Hey, Guns. Hello, Stephen. Hi, Python AI again. Yep, let's go. Let's go. Yep, exactly. We're making it happen. We're making it happen. Missed your chat messages, you guys. I just didn't have the window open. What do you think you're doing Christmas? We'll be enjoying time with the family, you guys. Thank you for the hearts. Thank you for the likes. Thank you so much. Yeah, happy holidays. Happy Christmas. Merry Christmas. What do you do on Christmas? We spend time with family. We'll eat food and we'll open presents. Happy holidays, Dark Sky. Happy holidays, Dark Sky. Welcome on in, you guys. It's because I sent you because I love coding. I love coding too, isn't it great? It's wonderful. It's one of the things I've always wanted to learn. So thank you. Hey, you're welcome. We're going to be doing that right now. I want to see if there's a way to do an average sum loss. Obviously, this is what we're already doing. We're already doing this. I knew how to do it. I was just wondering if there's a native Pytorch approach to calculating the cost. If anyone knows, let me know, because I'm seeing some obvious things in here that are things that I've already been doing these things. This is the way I would do it normally. So it seems like it doesn't need to be a native function because it's just so simple. That's why I think so. Steven, you use rclone for video stuff with the input. I have not used rclone. I do not know what that is. That's what you did? What is rclone? Let me see. rclone ffmpeg. What is this? You can mount Google Drive with rclone, but remember, what is rclone? Is it some sort of syncs your files from storage? Oh, okay, nice. Okay, nice. Yeah. I gotcha. What do you want for Christmas, Matthew Reisner? Happy, comfortable, and warmth. That's it. That's what I want. What do you want for Christmas? What do you guys want for Christmas? What do you want for Christmas? All right, I'm going to calculate the cost all on my own because I have a different approach that I suppose. Instead of a desktop app because you're on Linux. Oh, nice. Very nice. That makes sense. Use the rclone for that. All right, so can you hack Santa? Hey, Steve12, how's it going? You had to, of course, mention that. Can you hack Santa? Yep, you can always hack. Got to hack something every single time. Potentially, you can. I think you can basically hack anything you want. You can hack anything you want. All right. So where is our self.losses equals an array like that. Self losses equals array, and then where's our loss at? Loss is a function. We output self.losses.append loss. There we go. And then we can calculate cost. Cost. Thank you for the likes, you guys. Calculate the cost there. Cost. We will calculate the cost slightly with a variable name. So we will do cost equals sum of our losses. Thank you for the little heart icon showing up there. I see the floaty heart icons up there on YouTube, going on YouTube there. Thank you. CUSD cost loss sum. We should do, actually, how should we do this? Should we, I'm just going to do this over at len self.losses. Perfect. Okay. So there's the cost and there's the loss. The current batch loss, right? So the cost will start diverging and the loss should go as well. Okay. So let's try to run this. All right. Let's see if we get it. Let's see if it works. So a little warm up, just a little warm up. Okay. Click, click, click. All right. So what do we got our cost? So you see our cost there. Okay. Looking good. So I should be able to go back and forth, clicking back and forth like this, and it should learn my click pattern. What we need to do is increase the learning rate as well because we don't have so many clicks. So as you can see, their cost is dropping. So I'm going to keep clicking in the same spot. That should train. It's going the wrong direction. Why is it going the wrong direction? Wait, it should be, okay, now it's going the right direction. There we go. We just need to increase the learning rate. That's what we got. Ian Bradfield, a VR headset. I've always wanted one. I know I'm getting, thank you for the reactions, you guys. Henry H101 is a .22 LR. Your dad spent $451? That sounds really nice. That sounds really nice. I've done some VR back even like, what is it, 5 years ago now? Even more than 5 years ago. It was pretty neat. VR is pretty neat. It was good back then. I can't imagine how amazing it is now. It is fun. It's fun. Nice. It's nice. That's awesome. That's fantastic. All right, so my cost is dropping, looking good, and the loss is dropping as well. There we go. Yeah, now it's really getting... All right, so the cost is not cost the way I want it. Is it? See, the loss is doing great, but the cost should look different. Did I math it wrong? Did I math it wrong? Cost equals sum of losses divided the length. So it should just be the average. It didn't get me what I wanted because the loss is over here, which means basically the loss is the about the pixel density. The pixel. You mean it's a gun? Oh wait, is it? Oh, that's not what I. Okay, now the letters and numbers make sense. Okay, now the letters and numbers make sense. Can you hack the department? Oh well, yeah. I mean, usually no, because they're in an air gap, right? They have air gaps. You can't. That makes it hard. That makes it difficult. So yeah, Ian Bradfield, I got you. I understand now. I understand what you're talking about. So you mixed VR and then weapon, and I was confused. Like, wait, this sounds like it's like red one, but yeah, it was weapon. Okay, so we calculated the cost. It's not what I wanted to see, but it's fine. Let's increase the learning rate. Where do we do that? Where is that at here? We can figure that. Here we go. Learning rate. Let's go -1. Let's do -1. So let's like make it learn a lot really fast. Henry is the brand and H001 is the model. Oh, nice. We're learning new things. Ian Bradfield, thank you. Edward, hello everyone. How's it going, Edward? Good to see ya. Happy Merry Christmas. Okay, so let's try this again. Let's see how fast our clicker can learn. Click, click, click. It learns almost instantly. That's perfect. That's what I want. I want it to learn instantly. All right, click back and forth. Looks good. Okay. It is... Are we getting what do we want? So I'm trying to click in the same spot. Is it learning? So what we could do is... I think we could reduce the input features. And that might make it a little bit better. That might make it a little bit better. Okay. So what I'm looking at, if you can't see here on the screen, I'm looking at the numbers on the screen, and the loss should be as close to 0 as possible. That's what you want to see. That's what when a model is, getting generally good. Thank you for the hearts, you guys. Thank you for the heart icons. Okay. So if I keep clicking in the same spot, it's gonna learn pretty fast. Okay, looks good. Okay. Yeah, thank you for the heart icons there. Appreciate it. All the floaty heart icons. Okay, here we go. Check this out. So we've got a good learning rate. It's a little bit much. Don't get me wrong. The learning rate is a smidge high. We need it because we have a small amount of data. And all the 100s, I see the 100s there. Thank you. Think the 100s. All right. So we could also increase our resolution here. We could go to like 32. And we could reduce. So we might want to consider reducing right here, reducing the input dimensions. We could reduce the number of features. We could absolutely do that. That's something I'm considering. We could absolutely do that. So let's do 32, 32, 32, and 32. So let's give it a little more intelligence there. So it's a smidge bigger. And we could potentially reduce the input size. Let's go ahead and do that as well. So we'll do 4. So where was that at? 4/8. It's around here somewhere. Here we go. So we'll do 6 and 6. That should do it. That should make that work better. Okay. Here we go. All right. Click, click, click. Yep. Looking good. And the loss immediately bumps down immediately. Excellent. I love it. Okay. So let's try and... Okay. Okay. Hey, Kyle. Hi, all. Kyle, good to have you here. We were chatting a little earlier. I just got here. What are we looking at? Red light. We built an AI that tracks user clicks on the screen, and we'll be able to predict where the next click is. So we are going to start visualizing that right now. Right now on the screen, you really only see my clicks. Thank you for the reactions, you guys. So the plan is we're going to visualize that today. And that's like the most important thing that we need to do today is visualize it. We got started a little bit distracted. I got a little bit distracted. RG, how's it going? Hey, all, good to see you. Red light witchcraft, isn't it? We're predicting the future. It's like how all like stock algorithmic trading happens, right? Algorithmic trading, so you can get ahead of the curve there. Interesting. How do you come by this idea? Quantified Quantum, who is a regular and is a mod and the admin of our Discord server, has given us the idea to do this. It gave us the default base code, and we updated it by adding the AI aspects to it. How many hours do you sleep, bro? You always look fresh. Thank you. Carmu, thank you. Good to see you, Carmu. Happy Merry Christmas. I try to get about 8 hours. Oh, Savon. Oh, wait. Sorry, Savon. I forgot RG. Okay, Savon. I'll remember now, because on my screen it says RGIK5KW, and that's kind of hard to remember. It's a smidgen difficult to remember. Savon, good to see you. RG. Okay, Savon is RG. RG is 7. Unless you change your name somehow, which you might, because that happens regularly. So thank you for visiting. All right, so we did the cost. We reduced the inputs. We increased the learning rate because we've got, and so now I want to visualize it. I want to visualize it now. Yeah, that's a good YouTube weird thing. YouTube does that. Yeah, it does. It sure does. YouTube does it. I'm not sure. There might be a way to set the name. There's got to be, right? Because I've said it myself. I've said it myself before. So let's see here. Thank you for the hearts, you guys. Thank you for the reactions. All right. We need to visualize the dot now. That's like the one goal for today's stream. We need to visualize where the dot is going to go. All right. Let's see here. Where is our dots? Where are we printing the dots? Tries to find the way. All right. Sounds good. Tries to find the way. All right. So display where the AI thinks the output is. Okay. We don't need this anymore. All right. Get rid of some of that. Looks good. All right. Game width, window, looks good. Game. Excellent. Width, okay. Draw circle. This circle, I believe, is the center circle, which we don't need. So what we could do is just use this code right here to draw where the AI thinks the output's going to be. So let's go ahead and just grab that. Draw marker. Wait, hold on. Marker.draw. What is this? Point marker. Predictions point marker. Marker.draw. So this is where the user clicked. The marker is where the user clicked. What we want to do is I think what we could do is we'll just do this. We'll just draw it straight up. We'll draw it straight up, even though it's predicting the future and it might be affecting the outcome. Code is like humor. If you have to explain it, it's bad. That's a good way to say it. Because if you want your code clean, easy to read, understandable, otherwise it's bad, right? Otherwise it's bad. It's exactly like a joke. It's exactly like humor. If you have to explain it. All right, so we have the output here. So game.draw. So the output. Here we go. This is what we're looking for, the output. What is this? So why is this? Oh, okay. So that's the color. So we will draw it right here. Output. I think we could just say output, right? Can we just say output? Is that what we could say? I also want this red, green, blue. Can we increase this? I want it to be like a gold color. Can we make it gold? 22. There we go. So the AI is a golden color. I always imagine AI is like a bright, warm light, like a glow, like an Edison light bulb, something like that. All right. Click. Oh, game's not defined. Okay. Train. So, oh wait, self dot game. I think we could see game self dot game. We need to save the game. Self dot game equals game. So we'll save reference to it there. Excellent. Okay. Here we go. Click, click, click. Oh, game dot window dot screen. Why is that? All of a sudden, name game is not defined. Did you mean self dot game? Yes, I did. Although not really. So line 162. 162. Oh, okay, yes. Because we need access to the screen to blit the circle. We got to draw the circle. Okay. Here we go. No, still the problem. Okay. Where is it? Center argument must be pair of numbers. Okay, fine. Fine. So I suppose we'll just do it like this, I assume. Although, wait, is output... Hold on. Maybe, oh, wait. I think actually we can just do this. Output 0, right? 0, like that. I think. I'm pretty sure. Let's find out. Machine learning is 10% math and 90% gaslighting a computer until it agrees with your labels. It's true. It's well, essentially, yeah, you say, hey, AI, what's the answer to this? No, you're wrong, it's this. Hey, what's the answer to this? No, you're wrong, it's this. And then you keep that cycle until it remembers. Okay, so it didn't like that. Center argument must be a pair of numbers. Okay, so where is my output? All right, so let me see here. Output is, okay. Okay, I gotcha. Okay, so let's see. Can we do... It's like this. I guess output... We're going to try it the way that I think it needs to be. Although, I don't know because it's... Maybe. Well, let's see. No, actually, it's 100% math. Yeah, you're right. Yeah, it is. Yeah, it's called statistics. Yeah. 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 If we want to be accurate and reasonable about it, you're right. If we want to have precision in the argument with truth, yes. With accuracy. All right, here we go. Let's see if we can get this to go now. All right, click, click, click. Still's unhappy. Okay. It says it doesn't like this, even though we did. Oh, so and then it doesn't like 12. 2 lines. Center argument must be a pair of numbers. Okay. We're just trying to draw a circle. That's all we're trying to do. This is ridiculous. I don't use an iterative approach because all my AI code is perfect. Prompting skills issues. There, yeah, one shot. You got to one shot it. You one shot it, and you're good to go. Just have it go. All right. So, what is wrong with that? All right. Circle. Game.draw circle. Screen width, state, position, and a number. Oh, it must be the diameter. Or the radius, right? That's the diameter of the circle. Okay. The center is a 2-coordinate number. Yeah, that's what we're trying. Yeah, exactly, Sivan. That's why. Yeah, we need it to be a X and Y coordinate, right? So let's grab this really quick. Redo that. All right. So what are we looking at here? So this is the color. That's the color. This is the screen that we're blitting to. The output should be it right here, because we're looking at that right here. If you go like this, you're looking at the output. You see it right there, and it is 404 by 240. So that should work fine, I think. Although, when we are subscripting it, is it actually giving us our subscript value? So let's find out. Let's find out if it's giving us our subscript value. We will find out. Did that work? I think so. Let's find out if that works. Output. Maybe a tuple? Yeah, we might need to tupleize it, right? We might need to make it a tuple. So let's grab this. We will hide this for a second. Okay. Okay. All right. Click, click, click. Okay. So our output. Okay. So that's why. It's a reference to, so we need to like convert it. It's currently a tensor, but we're trying to access. So that's what it is. It's right here. So you see how we're subscripting it, and it returns the actual number that we want is 409. However, it's returning a tensor, and Pygame doesn't like that. Pygame doesn't like it. So we'll fix that. We'll fix that. Do we say how to get the data out from a tensor? How do we do that? Aki Codes, thank you for subscribing. Welcome on in. This channel is all about software engineering. We write code, make AI. We're focusing on AI, mostly Python and AI. We'll do Rust. We'll do some C. We'll do some JavaScript, right? Python. We could do other things if we wanted to. We might mess around. We've done assembly on the channel as well. We've done assembly. Right now, though, we're focusing on AI. Thank you for the hearts, you guys. Thank you for the heart icons shown up there, the reactions. Life is short. You need Python. There you go. Python is the way. It's fantastic because if we needed to add a performance, because Python is pretty slow comparatively to a compiled language like Rust and C. If we needed to, we could leverage the power of those faster languages, compile those as a module that we can import into Python, which is how most of the Python modules are written today. Well, maybe, I can't say most. Most are native Python. So many that require performance are written in other languages and imported through modules into Python. And that's how that works. All right, so let's keep going here. I want to get the output in a way that I can then draw it. I can draw it. Okay, that's what we want to do. We want to draw it right here. So the output subscript, we need to say chords equals output dot to something. How do we do that? How do we convert it back out? Can we do this? Can we say list? Can we do that? Is that something we can do? Will that work? Does the tensor have a dunder method to convert it to a list? Will that work? I don't know. Let's find out. Let us find out. Let's do this here. Chords. Okay, here we go. So we tried to compound data structures into the scalar values. Yes, that's what we need to do. That's what it expects. So it expects, it yelled at us. It sure did. It yelled at us. You got it. That's what's happening. All right. Let me see here. All right. The Python, the only language where white space is a lifestyle choice. It's heavily advised in Python. You can bypass some of the white space requirements, the indentation as syntax. You can do that. You absolutely can with backslashes, right? You can escape things and make them different. Although it's, for the most part, you have to use indentation as syntax. So it's on purpose as a style pattern in order for your code to be legible. That's what. Yeah. Got to keep our code legible. All right. Okay, let's try this again. Here we go. All right, click. Looks good now. All right, looks good. What is our chords? See, it's still a tensor. It's still a tensor. Dang. Okay. So there's got to be a method. All right. So let's look this up. All right. Let me see. Pytorch convert tensor to array. Let's just we're not using NumPy right now, so we don't need to include it. Right? Is there it just regular NumPy? Is that all it's going to give us? Or you should use detach. Okay, so there's something called detach. That might be what I'm looking for. If the tensor is part of a computational graph, requires gradients, you should use detach before CPU NumPy to prevent tracking operations. Oh, got it. That is interesting. Okay. I didn't know about that. I think we should be fine because the graph is done. It's the end of the graph. It's the end of the graph. So we should be able to, let's try it. Okay, we'll try it. Here we go. Okay, so our chords, will be output. And delete. Okay, detach. Okay, let's see if that works. Is it better now? Is it gonna be better now? Click, click, click. Okay, what does our output look like? Our chords are correct now. Okay, excellent. This looks like what we want right here. Okay, we're looking good now. We're looking good now. That's what we wanted. Okay, so 1 second. Chords. Let me double check though, really quick. Okay, yeah, all right. We did it. We did it, you guys. We did it. So let us get rid of that. We don't want that anymore. We're good there. No need that. I do want to print out the, what do you call it? Let's grab some of this back. I want the, yeah, I do want the chords. So let's grab that. Here we go. No, I still want that. Okay, looks good. So here's the coordinates. And now we can easily, I think maybe we should be able to paste that right there just fine. We'll find out. There we go. Get rid of that. Get rid of that. So detach pops one row out of the tensor as array. It goes a step further, right? So Savan, the way I understand it, when you're dealing with Pytorch and you operate on the tensor, like these types of operations, it overrides, obviously it captures those operations like a division, right? So let's look just at division. It will capture that as part of the graph. What that means is it's a series of operations. When you transition this over to a different device like a GPU, it can capture all of these mathematical operations and collapse them into a pipeline that makes it more performant. Additionally, it can be exported to a Pytorch file that can then be imported into another language like Rust or C++ for inference operations, for high performance inference. Mohammed, how's it going? Good. Merry Christmas. All right, so if we break the graph, then you can no longer export that data. You've essentially broken the graph at the point where it's not exportable anymore. It'll still work, which is what is perfectly fine for our current use case, because this is just for education purposes. It'll just break the graph. Wow, very cool. Isn't it neat? Yeah, it's these operations, like all of these operations will get saved into like a graph that can then get smushed down, and then you can say torch.optimize or something like that. And then it will merge all these operations into a streamlined pipeline, which improves training speed and inferencing speed at the same time. So it's like a double win. It's a double benefit. And I haven't used the optimize function yet. So we don't need to at all because it's very little amount of data. I still want to do that though. Let's add that in. All right, so let's add that on to do. Use torch optimize for graph collapse. This is what we want to do. We want to do this. So let's do that. All right, so we visualized it. Let me see here. Okay, so now for the first time ever, unless we needed something here, like we need to convert it into a tuple, we should be able to visualize where the AI thinks the click is going to go. So let's try it. Let's try it. Click, click, click. Okay, so almost. Chords 0. Okay, and chords 1. Now we should be fine. Maybe? I don't know. We'll find out. We'll find out. I'm pretty sure, right? Still no. Oh, come on. Okay. Self-game window screen. Center argument must be a pair of numbers. That's what we were doing. Okay. So it might not like this for some reason. Let's see. Game window screen is a display mode. Okay. Screen fill. Let's keep going here. What are we doing wrong? We're so close. We're so close. We're like one step away. So could you just replace input? Actually, that's a good idea. We could test that out. We could just draw something static on the screen. Let's do that. We'll just do like 60 and 60. Let's try that. Because this might be the problem here. Or we're just drawing it wrong. So let's grab this. So screen, color, position, diameter. Let's do 20 on that. Okay. So if this is good now, let's see. Let's see if that breaks. Okay, so that does not break. Also, you can see here a little. You can. I don't know if you can see it. It might not be showing up on YouTube. The circle appears only for a blip, only for a very short blip, only for one frame. We need to keep it on the screen longer. Okay, so I've got an idea. Good news. We've got good news. Let's see, chords 0, chords 1. Let's see if we can make that look like that. Okay. You see it? You do nice. We achieved our goal. I want to make it better though. I want to make it better. No name for you. That's nice Linux machine. It is. It's a Unix based system. You got it. Unix based. All right. So what I want to do is constantly draw the AI circle. We need to set some sort of accessible, maybe in the game object, we'll have like the AI prediction. You run Parrot. Parrot Linux. Is that what you say? Parrot Linux? Let's see here. Let's check this. Let's take a look at this. Parrot Linux. Parrot security. Download. Parrot OS. That's what it is. Parrot OS. Okay. What is Parrot OS? Let's take a look. Let's take a look at what Parrot OS is. All right, let's zoom in on it. Let's zoom in. Parrot OS, Parrot Security, Parrot OS. Oh, so Parrot OS is a free and open GNU Linux distribution based on Debian. All right, so Ubuntu, right? Debian. For security experts, developers, and privacy-aware people, includes a full portable arsenal for IT security and digital forensics operations. Woo! So it's like a competitor to Kali Linux. It also includes everything you need to develop your own programs or protect your privacy while surfing the internet. Nice hair today, Steven. Thank you. Hey, Quantified Quantum, how's it going? Merry Christmas. Merry Christmas, Quantified Quantum. Good to see you. Hey, I caught up with the stream. Just finished our Silk Song playthrough. You did? Did you? Okay, so Sam and I, we finished Act 2, essentially. We defeated the Silk Baroness or whatever. And our Silk Bar got really big. However, based on the internet telling us that we're not actually finished the game because there's an Act 3. There's an Act 3. If you can keep going. If you thought you finished the game, unless you actually beat Act 3. We're not even in Act 3 yet. We tried to get there last weekend. We didn't make it. It's a kernel. Why they named it OS? It's defensive security. Nice. Defensive security. Like Black Hat Linux. It seems like a dual purpose, like Black Hat and White Hat, right? So forensics is, that means you're more offensive, right? And then there's also some protection, so defensive for protecting your privacy. Kali is a hammer, Parrot is a scalpel. Oh, there we go. We're learning new things. You finish your FFmpeg script? Kyle, that's awesome. Send it in Discord. You DM you and look if you got time. Sure, I'll be happy to take a look. Tell you if they implement Gemini to make cuts based on sound. Yeah, there you go. So you could do volume, right? You could do dBs, right? Decibels. You can grab the decibel, the sound, the volume levels to capture that. You could also do cutting the silence, right? So there's silent removal. You can cut silence. You could also use the audio volume level in addition to transcriptions to have the AI cut the video for you automatically. You can do that. That's what I did. That's how I did it. Just doing a side quest before I challenged the Act 1 boss. Oh yeah, we did all the side quests. That's basically what we spent all of our time on. You have to get all the maps. You have to get every map before you can get, and then I think you have to get something else, and then you can go to Act 3. So like that's where we're stuck. We have to get. We're trying to get Act 3. Oh, and you're planning a YouTube upload. Nice. Do it. That would be great. Make it happen. Okay, let's get back to... Oh, by the way, Quantified Quantum, we're almost done with adding AI to predict the clicks. We're almost done. We almost did it. Game.ai. Can we do another marker? Where is that? Where's it? Point marker. Okay. Can we do this? We don't need a point marker. We just need a simple X and Y coordinate. So where do we want that at? We could put it. Where do we want to put it? I think game. Here we go. Game. Perfect. Okay. Draw AI. How about this? Yeah. AI. We'll just say AI will be a list. All right. We'll do that. We'll do that. And it will be an XY coordinate. That's what we're looking for. You did cuts based on audio. Yeah, we did audio and transcription. So audio decibel levels. So that way we cut the silence, but audio decibel levels to detect like maybe excitement, to intend like tone, things like that. And additionally, we transcribed the audio and then timestamped it. You can transcribe the audio down to every single word. So on the word level, so you get every single word at every single moment. And then you capture that information, and then you have the AI edit based on whatever input you want, right? So you give the AI the ability to see what the video content is, and then you submit a prompt using tool calling and function calling to edit the video. And then it gives you timestamps, and then use FFmpeg to capture each of those segments of the video that are relevant to your edit request. And then you concatenate them all in the end. And there you go! You've got an edited video pipeline system. Isn't that neat? I think it's pretty neat. Okay, so here's the AI coordinates. Where is that? All right, AI equals empty list. Okay. What I got? Cuts based on sentiment. You could do that too. I have not done that. I've not gone extra steps. I have just essentially using the LLM to do that work for me, the sentiment. We could take segments and extract the transcripts and then add NLP on top of it, right? You could do NLP additionally and then provide that NLP, positive, negative sentiment, natural language processing, as additional input when you're having the AI edit the video. So now you're thinking, see, we could create like a whole business on this, right? Actually, multiple people have asked me to do it. They say, you should do this. You should make a business. And in fact, there is a business that does this. I think already it's called Descript, right? I think it's called Descript. Check this out. Descript. Here you go. It's this right here. Direct your AI co-editor to edit videos for you, and it will automatically edit the video the way you want. It's called Descript. So there is a business for it, and they've done everything. So you get podcasting, captions, templates, jumpstart your workflow with a battle-tested AI template. So if you want to make like a documentary and you just want to shoot the footage, B-roll and A-roll, it'll be able to capture that and do all the editing for you. It's pretty neat. So there's a business out there. There's a business. You can make it happen. Where can I start to learn all of these? I'm a bit familiar with Python. Oh, are you Francois? Or are you Francis Elvis? I think you're Francis Elvis. Okay. I'm trying to read your name there. So Python, a really good place to start is, just the general tutorial on the Python website. So go to python.org, right? Python.org, maybe? Yeah, here you go. And then you can zoom in, and then there is a little built-in editor here, which you can interact with in live. So you can actually interact with this. So it's a good way to get started. Launch interactive shell. So you click this button, maybe 0 here, interactive shell. Here you go. And then you zoom in more, and then we zoom in more over here. Okay. Well, all right. We'll just zoom in like that. Here we go. And then you can say 1 + 1, and then there you go. And you can say if true. Let's see, print 1, right? Oh wait. Oh, it's not capital T. Oh wait, I got to spell true correctly. That's what I got to do. We're figuring things out here, aren't we? There you go. See it, print 1. There you go. So it's a decent way to get started. It's just to mess with the online website directly. Then you can get deeper, get through the documentation, go through beginner's guides. There's a whole bunch of options here. Well, you've got subtitles on live. This is trippy, isn't it? Whoopty, whoopty, isn't it neat? I think it's pretty neat. It's pretty good too. It's pretty good. Whoa, you got Stephen. How is your current live subtitles working? Is it your library? Yeah, it is. It is. So Stephen LB Twitch. Here we go. Yeah, this is my library. I wrote it 7 years ago, and it still works today. It works really well. It works very well. Isn't it neat? Isn't that neat? Works pretty well. Hello, welcome to my stream. We'll be playing games today. Just import this. Yeah, exactly. It's really easy. It's a quick and easy install. You just copy and paste a few things, and you're done. It's just a copy and paste. It's easy. You got it. You got it. Okay. Yep. Okay. All right. Let's get back to our game. So quantify quantum, we're almost there. So we're just adding the coordinates for the AI. Coordinates for the AI prediction. Right there. Right there. And then we'll just, actually what we do is we'll say like 500 comma 500 just to get it started. Although that's too much. So we'll say 250. 250 and 450. All right, there we go. So this will be the center of the screen right there. We'll put it in the center of the screen. No, type it in the PSF online terminal. Oh, all right. Let's try it. I don't know what that does. Okay. Import this. It did something. What did it do? The Zen of Python. Whoa, what? Beautiful is better than ugly. Explicit is better than implicit. Simple is better than complex. I didn't know about this. Look at this by Tim Peters, who is probably the creator of Python. No, who's Tim Peters? Peters is a software developer for creating Tim hybrid algorithms for a major contribution to the Python programming language in its original C Python implementation. That is neat. Hey, Savon, thank you. I didn't know you could do that. Errors. So let's read it. Let's read it. Tim Peters put this on for us to read. So let's read this really quick. We're gonna take a little break. We'll read it. I won't LJS. What is LJS? Quantify quantum. Quantify quantum. Good news. We're almost done with your request. We've got the AI. It's predicting where the clicks are occurring. It's doing a pretty good job. All right, let's read it. All right, beautiful is better than ugly. Explicit is better than implicit. Simple is better than complex. Complex is better than complicated. Flat is better than nested. Sparse is better than dense. Readability counts. It's not illegible. Better than legibility. All right. Special cases aren't special enough to break the rules. Although practically beats purity. Okay. Practicality beats purity. All right. Errors should never pass silently unless explicitly silenced. Seems fair. In the face of ambiguity, refuse the temptation to guess. Seems fair. All right. So there should be, so essentially if there's something ambiguous, fail. That's what it's saying. It's programming poetry. It definitely is. There should be one, and preferably only one, obvious way to do it. Okay, so keep it clean. So if there's a whole bunch of different ways to do the same thing, that means we've got a problem because you've created a learning curve that is constant in the language. That makes sense. I like it. Although that way we may not be obvious at first unless you're Dutch. What? Wait, hold on. Wait. Wait a second. Although that way may not be obvious at first unless you're Dutch. Okay, so there must be some colloquialism or something that is going on that I don't get. Seems like an initial systems prompt for all my projects. That's actually a really good idea. This could be like baked into the system prompt. It should be baked in. Now is better than never, although never is often better than right now. Really? I don't know about that. Maybe. If the implementation is hard to explain, it's a bad idea. The implementation is easy to explain. It's maybe a good idea. It's not guaranteed to be a good idea, but it might likely be. Namespaces are one hunking great idea. Let's do more of these. More of those. Okay. Excellent. Hey, we did it. Floaty devs. Time to become Dutch. It's the time to become Dutch, right? Because we will understand a little bit better this coding poetry in Python. You're biologically Finnish, like Linus? Really, Kyle? Like Linus Torvald, like the creator of Linux? Or Linus from like Linus YouTube Tech? You're probably talking about Torvald. We did it. All right, so let's finish this off. Let's finish this project here. We're going to do it. So the AI is going to be center, and then we're going to be updating the coordinates of the AI. So where is this at? Here we go. I want this to be, get rid of that. No, wait, yes, we want that. This is a to-do item equals 10, 10, just to let it know that we're getting that right. And then this will be AI 1 and 2. Here we go. Let's see here. Oh, and then we paste that there. 1. We go over here and go 0. That should work. I'm pretty sure. Let us go. All right, here. Okay. Is that? Yeah, that's right there. Okay. Excellent. Hello, Guten. Hello, Guten. You're saying some Dutch things, probably. Best. Okay. So that should work, I think. I'm pretty sure. We're going to find out. We will find out. Let's see. That should be a constant circle. Oh, all right. Yeah. It's a little syntax error. We don't need that. We don't need that. There we go. Okay. Better now, maybe? Yep, here we go. All right. Excellent. Perfect. Okay. So let us finally get this working properly. Here we go. Chords. So, wait, hold on a second. Chords is a float, an NP float. Can we do like int on it or something? So let's do chords 0 int. Like that. Right? I think that's good. Increase. Go. Done. Set AI prediction pixel XY chords. There we go. Perfect. YouTube mime. How's it going, YouTube? YT. Good to see you there. Okay, so let's run this now, and we should have it done. It should be done. Yep, there it is. Isn't that neat? There it is. Oh, see, they get the AI. It's learning where the clicks are happening. You can see it. That's pretty neat. Isn't that nifty? Hey, we did it. I mean, there's probably a whole bunch of different ways to do it, right? A whole bunch of different ways. Is it grabbing the pattern though? So thank you for the party poppers. We did it, you guys. We did it. It's pretty good. Now we can optimize it because right now it's just we're updating the weights and the parameters. But we could probably do this a little differently, right? Because it's reinforcement learning. So we could probably make it better. We did it, you guys. Thank you for the party poppers. I tried to get Finnish dual citizenship, and your last name is a popular Finnish word, and they still denied you. No way, Kyle. Really? That's unfortunate. Thank you. We did it, you guys. We did it. It's very hard to move there. They don't want you. Wow, that's ridiculous. They should want you. Why don't they want you? We did it. All right, so now I'm going to commit the code. We're going to push it to Git, and we will see if we can maybe mess around with this a bit to maybe make it a little bit different. Maybe do a slightly different training rate, things like that. Steven, use multi-agents and pick a mean. You mean an average? Oh, that's a good idea. That's a really good idea. So, you could use multiple agents that make decisions. So imagine like you're running a local GPT OSS, you're accessing GPT 5.2, Claude Sonnet 1.4.5 or 5, whatever is the latest version. You're doing Gemini, and you ask all the AIs for all of their thoughts using a deterministic output format with JSON what do you call it? I guess, or function calling, right? You could do that, average across all the agents, and get the best possible answer. Well, I guess the average answer, right? Pick the mean. That's a good way to do it. That's a good way to do it, Quantify Quantum. All right. So let me go ahead and commit this. Close this. Get status. Get commit. Success. Party popper. And maybe another party popper. And we'll paste that over. Okay. Success, done. Push, main, done. Okay. Kyle is attempting to say some words that I do not understand to Sivan. And I don't know what you mean. Now add a training mode in which multiple AI learn from you and each other. Wait, what? Wait, I don't get it. Oh, so what? I need more. I need more information. I need more information. Okay, so let me see here. That's one of my bedsheet agents. Oh yeah, examples. Multiple ALM judge. It's a judge. It's a common eval method for models and agents, is it? Sivan, that's awesome. That's fantastic. Why not make an AI agent or an agent use Streamlit as a temporary front, so a UI, a front end, and use Hugging Face to edit input images? That would also work. I mean, everything you guys are saying is right. You could absolutely do that. Give it a limit though. Oh yeah. You don't want it to be unbounded. You do not want it to be unbounded. Add multiple AI followers in the loop. Just get more data. That would be. We could do that. We could absolutely do that. That would work. Add multiple AI followers in the loop, just to get more data. Got it. Okay. So we could stack it. That could be another thing to do. I made a wrapper 3 months ago using Gemini APIs. Turns out Google changed their code and it broke. No! Leaf Gang, no! Isn't that terrible when that happens? Isn't that awful? I think that's rough. That's a rough situation. All right, we did it. Oh, wait, we should try. I want to do this. Okay, so we did this. We did this. Let's get rid of these. We didn't do this yet. So how do we compile the graph? Do we say just compile? Do we say model compile? Is that what we do? I think so. I think we say model model.compile. So let's look this up. All right. Torch compile. Pytorch compile. What does this do? What is this? Okay. It's the new way to speed up your Pytorch code. Makes Pytorch code run faster with a JIT optimized kernel. Oh, optimize the kernels. Okay, while requiring minimal code changes. Accomplishes this best. Okay, so how do we use it? Okay, how does it work? Accomplish this by tracing through your Python code, looking for Pytorch operations, right? The graph code that is difficult to trace with results of breaking graph. See, I told you about this. I wasn't making it up. I was using the right terms the whole time. I was wondering about it. I'm like, am I saying the right words? Was I saying the right words? I don't know. But it was a graph. That's the way they call it as well. They call it that way as well. Hi, remember me? Karuthika? How's it going, Karuthika? Good to see you. Or AutoGen bot, which two bots or an agent interact with each other. Meaning, if I want the code, one agent sends it to me, and that agent sends it back and checks if it's right or not, then sends it. Yeah, you can stack it, right? You can have a pipeline. You can definitely do that. That's one of the common patterns, actually. That actually is a really good idea. That's a really good idea. Steven, check out Avi project. The Avi project? Okay, I will. Quantify Quantum. Let's do it. Let's check out AVAE project. What is this? Okay. DNS. Why are you having me look at DNS stuff? Most commonly refers to free Linux focused implementation of MDNS. Automatic local network service discovery. Printers, files, chats. Why Quantify Quantum? Why? Linux component for zero configuration networking. Sounds good to me. Allows applications to find services like printers and shared folders. Works with Apple. Bjorn. Technology often found in macOS and iOS as well. Nice. The more you know. Thank you for the hearts, you guys. Thank you for the hearts. Or send it back and make it right. Yeah, there you go. That's a good way to do it. Like up the live, y'all. Sub, Steven's the best live software engineer online. Thank you, Kyle. Thank you for saying that. That's really great feedback. Thank you for the heart icons and all the reactions, you guys. Where are you from, buddy? Over here in Seattle, Washington, United States. We're in Seattle, Washington, United States. And see, I was in Silicon Valley in San Francisco for a few decades. It worked out nicely. I liked it. And then I moved back home. That's how that works. Wrong thing. Oh, Ashy Project. Okay, got it. Typo. A-S-A... Wait, did I type it right? Wait, hold on. A-S-A high. Did I say... Okay. Ashi Linux. Okay, Quantified Quantum. That's better. The Voss. Hey, how's it going? Hi. Hi, Aran. Hey, how's it going? From Pakistan. All right. There you go. We got some folks from Pakistan in here. Multiple people. All right, so we've got Linux on Apple Silicon. Oh. Acai Linux, you guys. Acai Linux aims to bring a polished Linux experience on Apple Silicon Macs. That is very nice. All right. I kind of like it. I kind of like this. You're from Iran. Nice. All right. So we got Iran and some Pakistan in here. Here we go. Software engineers are everywhere in the world. We're all over the place. We're everywhere, you guys. Okay. This is great. Quantified Quantum, thank you for sharing this. I am running Mac hardware and would very much enjoy to leverage this at some point here in the future. This is really neat. Thank you. Thank you. All right, I want the compile. Let's go back to the compile. That's kind of cool, isn't it? It's pretty great. So where's my compile at? Breaking the ref, okay. Which are lost optimization opportunities rather than errors or silent. Yes, okay. So I want to use Torch compile. How do I use it? How do I use Torch compile? I've heard about it. Okay, torch.compile foo. Foo? Oh, what? How? So you can also use an at compile. Okay, so what does the at compile look like? Because I could just do that. I like that idea. Let's try at compile. We'll try at compile. We'll see if it works, you guys. We'll see if it works. Engineering, mechanical, and software coding. There you go. I like it. So many great technologies to enjoy. Let us go here. All right, can we do that? Will that work? I don't know. Wow, thanks, Oliver. You're welcome. All right, so I hope this will work. Let's see if this works or not. You made a rag bot for books, meaning if you upload the Harry Potter book, it made chunks. Nice, you got to chunk it for the rag. When you ask something about the book, it gives you the phrase and also made pictures of it. Really? Hey, that's actually a really great tool. That's a fantastic tool. It didn't like that. Why not? Are we importing Torch? We're importing Torch. It doesn't like it on this, I guess. Here we go. Why doesn't it like that? Too much stuff? Is it? There's a lot of stuff around. The stream is designed for humans. Yeah, exactly. If you're an AI, there might be a little too much going on. Might be a little too much. Downgrade Python. Oh, wait. Python. Oh, dash version. Got it. Okay. We're on a pretty new version. All right, Quantified Quantum. Thank you for mentioning it. Looks like... I mean, I should be reading the errors. Why don't you just read the errors, Steven? That's what you got to say. Just read. It's the issue with 314. All right. Got it. We don't necessarily need to compile it. We don't. I was just doing it for fun because it's not that much. All right. So torch.compile foo. Let's try this. We'll try this instead. Here we go. Like this. Predictor. Paste. And in the line. There we go. Thank you. Let's see if that works. Do you think that'll work? Do you use UVcorn? Yeah, UVcorn for hosting. UVcorn for like Fast API. You use Fast API, then you could use UVcorn. You could do that. UVcorn, you got it. Use the UV Python manager, Steven. Trust me, it's a lifesaver. UV is better than pip, is what you're saying. UV is better than pip. Good to know. All right, Python main. Okay, so it also doesn't like that. Okay, it's not supported on 3.4. Okay, so we just won't be using that, which is there's no problem with it because there's not enough data for it to matter. We were just trying it for fun. All right, so let's see if we have any to-do items left here. Wait. Yes. Oh, post. Got it. Okay, yeah, perfect. Okay. Looks good. We figured that out. We don't need to do that. We really don't. We're just going to keep it in CPU. We used Optimizer. We did that. All right, there. That's it. We did it. All the to-dos are done. All the to-dos are use UV13 and set 3.13 on the project. That would work. That could definitely work. We can make that work. There's a command for it. Nice. I showed my dad pop install requirement file, and he thought I did something. Do you mean pip install? Do you mean pip install, right? Just checking. All right. Okay. I think we did it, you guys. I think we did it. Pip install. It was pip install. Okay. The live stream cut based on sentiment analysis of comments. That would be a terrible, probably. I know that would be pretty interesting though. It would be pretty interesting to see based on the comments. Yeah, that would be pretty great. That would be amazing. UV is like cargo for Python. It is. It's okay. So it's even better than pip. So you're saying it's better than pip because it's not just it's not just the managing packages or downloading packages and dependencies. It allows you to build packages as well. Superior fast package management. Yeah, it is. Nice. Very nice. Hutha. What do you mean Hutha? The Vas. What do you mean the Hutha? Okay. Sup, LT Mods. How's it going, LT Mods? Good to see you. Merry Christmas. Merry Christmas. So we achieved everything. So git status, git commit, cleaned up. Let's see. Wait. We finished all to-dos. Let's do a party popper there. Of course. Then we push, git push or origin main. There we go. Perfect. Coding before Christmas and on Christmas and after too. All around. I'm going to hello world rest Steven. Wish me luck. All right, Kyle. Enjoy. No AI. That's the way to do it. Got to have the pain. You got to have the pain. Suggest a roadmap. Okay. Suggest a roadmap to learn AI and machine learning. You're a developer who knows C and C++. I recommend Python, all right, Pytorch. I actually, if you're really getting started, I recommend going to this here. Look at TensorFlow Keras. It's a lot easier. There's fewer lines of code to deal with, and it teaches you what you need to know as the foundation for AI. Start with TensorFlow Keras. TensorFlow Keras, I think it's great. It's a lot easier, and it works. It is in Python. There are also Java. You could also do it in C and C++, although I recommend Python just for its simplicity. I recommend Python for simplicity. I gotta go check out Rust. Haven't touched it in 5 months. It's been great. So you just Rust up. Just run Rust up, get the latest, and you're good to go. The streams happen every day, every Monday through Friday. We do Monday through Friday. Seinheisel is a bad word. Is it? I don't know. It could be in another language. Yeah, it could be. LT Mods, I'm taking my break now. Great job recently for radio channel. Thank you. Excellent. Thank you for the hearts, guys. Thank you for the likes. Developing their site and keeping up their servers where the broadcast go. Christmas break. Yeah, there you go. LT Mods, you're on the right track. All right, you guys, we did it. We achieved our objective for today. We were able to get the AI. I wonder if we can make it better, though. We could probably try some different improvements, but we did it. We succeeded. Click, right? Clicking where the circle is. Yeah, see, it learns. It's not doing very good. I mean, don't get me wrong. It's not very good, but it eventually gets there. Eventually figures it out. Thank you for all the party poppers, you guys. Thank you for the likes. We did it, you guys. We succeeded. You know, Sri Lanka. I know of Sri Lanka. I know of it. All right, you guys. So that was we achieved the objective for the stream. Hi again. Oh, Eddie Demon. Hi, I'm here again. Am I too late? Yes, we're wrapping up. We're done with the stream. We achieved our objective. You can see the AI is somewhat predicting where the user is clicking next. Somewhat. It's not great. We need to improve it, but it is improving. Where'd it go? Here, right here we go. Yeah. So it sort of works. It's slightly okay. Git repo? Oh yeah, we got it. I'll update the graphics. Nice. Definitely make that happen. Steven, hear me out. Okay. We'll hear you out. Before we head it out, before we quantify quantum, let me know what you mean. Let's add hot spots feature. Ooh, nice, Savan. That's a good idea. That is a good idea. Hot spots, so we can see where things have happened over time. We could absolutely do that. That's a good one. That's a great one. Is it on GitHub? We did. It's on GitHub. It's over here on our Discord channel, you guys. It's on our Discord. Go over to free resources, and it is right around here. Click prediction AI right here. Click prediction AI, and it's sort of okay. It works. Don't get me wrong. It's just it needs to be better. It can be a lot better. Yeah, I'm DMing with your bosses like old pals, just sending Christmas. Nice. Just sending Christmas messages of good. Oh well, pretty interesting nonetheless. We did it, Eddie Demon. We did it. Run a random loop 1,000,000 times with random points for clicks. Oh, train it. Oh, there you go. Quantified quantum. That is a much better. That is a lot better than having to click myself, right? That is a lot better than clicking myself. All right, I'm gonna do it. All right, so that'll be in the next stream. We'll do that next stream. All right, so we've got to add some more to-dos here. All right, so Savan came up with some good to-dos, and we've got a few to-dos here. To-do. Here we go. Paste. Okay, so first to-do is add random clicks for lots of training data. Improve model for better accuracy. And then Savan said hot spots, like heat map, like a heat map. There we go. Now I'm going to commit that really quick for the to-do items, and then we're good to go. Come over, take your Christmas break, go with your parents, and enjoy the Christmas food. It's worth it, isn't it? It's great. So random loop data, add that, and random clicks in a loop for training data. Okay, we got it. I want to learn Python, but it's hard to find a suitable course in Sri Lanka. Even I found one, it's expensive. Oh, got it. Okay. Well, what you could do is use ChatGPT and have it teach you in Sri Lanka, and have it create a course for you automatically. That would work. That would work very well. Also mainly develop in PHP and JavaScript, MySQL, libraries, frameworks. That's how I wrote. You do it. You're doing it the right way. The language of the internet. You speak the language of the internet. Heat map, precisely. Yeah, heat map. We know what's happening. All right, so let's commit that. Close. All right, git status, git commit AM. Added to-dos for next stream. We did it, you guys, for next stream for tomorrow. We'll be live tomorrow. Push to the main. We did it. Oh wait, Quantified Quantum says Voss, Quantified Quantum can help. Join our Discord and send Quantified Quantum a direct message, and Quantified Quantum will be able to help you. Join the Discord. Geechee, hey Geechee man, Merry Christmas. Welcome on in. Happy to have you here. Okay, love your positive attitude. Subbed. Nice, thank you, LT Mods. Thank you. We'll be live tomorrow again. We'll be doing the to-do. So the to-do items right here. We'll grab those. Items. Yep. Right here. Let's highlight those and make them really bright. There you go. Extra bright on the screen. There you go. I like it. Extra brightness. Double highlighting. Yes, I like join your Discord. And that's excellent. Great. Domain hunt. Domain hunt. Great going. Thank you. Great going. All right. We did it, you guys. Thank you for all the hearts. Thank you for all the likes. We'll be back tomorrow. We'll be doing the to-do items that you see on the screen, and we'll make an improvement for our AI training. And we probably need to adjust the learning rate as well. And learning rate. Make that better. Learning paste. There you go. What a nice and happy streams we have here. Yeah, thank you, Savan. Thank you. Ultimods, man, I'm going to enjoy my break now. Going to do some maintenance on the radio's VPS server on January. Nice. Sounds great to me. All right, I'm going to head out. We'll be back tomorrow. Bye, everyone. Thank you for spending time with me on your holiday. We'll be back tomorrow, and we'll be doing some more holiday coding. See you guys.